All right. Looks like we are live. Let me know in the chat if you can hear me. For anyone that's here, put a plus in the chat if you can hear me. That would be amazing. I know it takes some time to get it going. Madison, welcome. That's a new name. Welcome to today's live lesson. Amazing. Thank you for the plus. Thank you for letting me know you can hear me and I'm not just in my own world here talking to myself. Daniel, welcome back. All right. Well, I already see one returning student. If you're a returning student, put an R in the chat. And if you're new here today, put an N in the chat. That'd be really fun. Raymond's in the chat, modding for me today. Amazing. Thank you, Raymond. Amy's here as well. Daniel is returning. Yes, welcome back, Daniel. Super excited to have you here tonight. Learn some geometry, learn some interior and exterior angles. Amazing. All right, wow. Off to a great start today, y'all. Great. New and returning. Awesome. Just a reminder, the workbook, with every lesson you get from me, you will have a professionally designed workbook, and you can find that in the video description down below. So it should be the first link there in the video description for this lesson. You can open that up, and this workbook is designed so that you can save a lot of time, right? In schools, I know a lot of the time you're just copying things down frantically, not trying to miss anything, but you won't have to do anything like that with me. The workbooks are designed so that you can just follow along, right? You can just follow along with my lesson. You can just fill in kind of like a graphic organizer, so you can just focus on the learning, right? Not just copying things down off of the board. Amazing. All right. Well, you're in the right place if you're here for geometry. This is my free live lesson, weekly free live lesson on geometry. Today we're talking about interior and exterior angles. Before I introduce myself, if you know anyone that might benefit from this, right? If you know any friends, family friends, anyone who you think would benefit from this, copy that link at the top of the YouTube stream, or, click on share, copy link, add it to your group chats. Let everyone hang out tonight in this lesson, in this free lesson on geometry, interior and exterior angles. Ahmed's here. Welcome, Ahmed. Can't believe you're here. We got some celebrities in the chat today. Amazing. All right, we got the whole gang here. Awesome. So just to introduce myself a little bit, I'm Eddie. I'm the senior math teacher at my EdSpace. I've been teaching in high schools and colleges for 9 years. I have private tutoring experience from every grade level, at every grade level, from 6th grade math all the way to students preparing for graduate school. So I have a really wide range of experience. I've taught over 2,000 students. So you can kind of say I basically have, dealt with the majority of types of students. So really excited to have you here today. I did really well in school, got A's in all my math classes, got 5s on my AP exams, got a perfect score on the SAT, and got into my dream school, UCLA. I graduated from UCLA with a degree in pure mathematics and decided to go into teaching right away. Found really early that I love teaching. I'm passionate about teaching math. And I guess that's part of the reason why my students have gotten into the top universities nationwide. And they've exceeded the standard, above national averages on almost every metric, 5s on AP exams, perfect scores on the SATs. But most importantly, they had fun doing it. They had fun learning math. And that's what we're here for today. That's what I'm here to show you tonight. How you can have fun, how I can make math fun and approachable and make you the next generation of math geniuses. So really excited to... really excited you're here and really excited to show you what I planned for you tonight. Yes, you can click below the title. Daniel, Raymond, thank you for helping out Madison get to that workbook. All right. I love starting out my lessons with a vibe check. So a vibe check is kind of get your gears running again. I know some of you might have just gotten home from extracurriculars, or maybe just had dinner, getting food coma, whatever it is. This is the time that my geometry course will start at around 6 p.m. Pacific time, starting on October 6th. So I like to start with something like a vibe check or an APK, and we'll look at that later. Before this vibe check, name all the ways you think these two images can be related. On the left, I see Probably someone building something. It looks like it could be their backyard. It could be construction, but it looks like they're hammering a nail into some wood. And then on the picture on the right, I see a baseball player making contact with the ball, which is actually a really, really difficult thing to do, but they're making contact with the ball. They have tools. Great, Daniel. They both have tools. One has a hammer, one has a baseball bat. Amazing. Is there anything else that you notice? Anyone in the chat? Anything that you notice about how these two images can be related? If I were to draw some things here, I notice that the hammer is coming down at an angle that's not particularly aligned with the nail. Swinging motion, great, Daniel, great observation. I see here another angle, right? And then a couple more angles here and here as well. You can see that the bat makes an angle with the ball as well. It kind of looks like it could be a right angle as well, which is kind of cool. But all this to say, both of these images are related because they use angles in real life, right? When you're striking something in a swinging motion, whether it be a swinging motion or just a little tap, you're exerting some type of force. And later in physics, in engineering, you're going to be using all types of angles. And our knowledge about interior and exterior angles is crucial to understand those situations and applications in the future. So to start us off, this is a APK, accessing some prior knowledge so that you're able to access other things in the lesson later on. Even if you've heard of this topic before, I can almost guarantee that the challenging problems that I put in at the end of every lesson will be challenging for you as well, even if you've learned this before. So let's take a look. Here's the APK. The angles in a triangle add up to how many degrees? In the chat. In the angles in a triangle, the three angles in a triangle add up to how many degrees? Let me know in the chat. Hi, Gary. Welcome. All right, Daniel, super quick with it. I mean, Daniel's been here before, so he knows everything. I'm super excited to have you here again, Daniel. Hopefully, I'm pretty sure you're going to catch something new today, and that's what I'm most excited for you about, right? You're here for, I think, a second time, and I can't wait for the new things you're going to learn today from today's lesson. The angles in a triangle add up to, Daniel is correct, 180 degrees. How can we prove that the angles in a quadrilateral add up to 360 degrees? What's a quadrilateral? In the chat. What is a quadrilateral? Anyone know what a quadrilateral is? Quadrilateral. Quad. We can break up this word a little bit. Quad does mean four. Quad means four. Great, Jiyoung. Four. Yes. Thingy with four sides. A shape with four sides is called a quadrilateral. Amazing. Yes. So any shape, any two-dimensional shape, four-sided shape, great, Jiyoung. So we have four sides here, and that's a quadrilateral, right? It might be kind of like a rhombus here, or maybe even a parallelogram, but a quadrilateral nonetheless. Like a square, a rectangle, all quadrilaterals. Now, why do the angles in a quadrilateral add up to 360 degrees? Well, that's because if we split or connected two of the vertices, notice how we have one and two triangles. And we know that all the angles in a triangle add up to 180 degrees. So you go, okay, that'll be 180 degrees times 2, and that equals 360 degrees. Oh, Kushi, welcome. Oh, I thought it was Kushi. Oh, yeah, that's right. Okay, Gary, thanks for joining again. Oh, you're a returner as well. Welcome back. Amazing. Just the same as Daniel, I'm excited to see what more you'll learn today. Let's see if we can find a general formula with any shape. Find the sum of the interior angles for the following shapes by dividing them up into triangles. So I'm actually going to exit out of this PowerPoint here so that I can draw some nicer lines. I'm going to go insert shape line, and let's split this pentagon into triangles. So I can connect a couple of the vertices here. I'm going to draw another line. And how many triangles do you see based off the lines that I just drew? Oh, great, Daniel, you got there before me. 3 triangles, right? That's what we see. 3 triangles. Let's go ahead and do this for all of the shapes. So if I have this hexagon, great, Gary, this hexagon, how many triangles do you think this hexagon will be split into? Oof. Looks like it's kind of locked there, huh? Maybe I'll just not completely go all the way. And then I can do this. Maybe I'll just go like that. A little off, but still straighter lines than I could ever draw. So we'll make it work. All right, there we go. It looks like we have 4 triangles this time for the hexagon. Amazing. Chidima, welcome. Great. Love the participation, everybody. Let's keep it up. Great, Daniel. And for the heptagon, how many triangles do we see? Let's go ahead and connect these vertices. Oftentimes in math, we have to pay attention to detail. I'm trying to draw these as straight as possible. If I were freehanding these, it would not turn out as good as this, which is why I decided to go with these straighter lines in shapes. And it looks like for the heptagon, hepta meaning 7, oops, that is a line, or that is a ray. Pretty cool. Let's delete that. It would have been funny if we left it there as well. And boom, there it is. This time with a 7-sided shape, we have 1, 2, 3, 4, 5 triangles. This time 5 triangles. Great, Chidima. All right. Great, Gary. I see you got it. You got it wrong at first, but you fixed your answer. Wow. Great that happened this early. Just a reminder, the brain research shows that whenever you make a mistake and you fix that mistake, that's when the real learning happened. That's when you really retain the information. So don't be afraid to make mistakes. Ask all the questions, participate, and you're going to be well on your way. So we have 1, 2, 3 triangles. For a pentagon, penta meaning 5, we have 180 degrees times 3, and that's equal to 540 degrees. Ooh, Chiyoung already knows this. So hexa means 6-sided. And this time we have 1, 2, 3, 4 triangles. So we'll go 180 degrees times 4, which is equal to 720 degrees. And then for a heptagon, what do we get? We have 4 or 5 triangles. What's 180 times 5? In the chat. What's 180 times 5? I see Daniel gave me the 540 earlier. Amazing. 180 times 5. Everyone frantically getting out their calculators on their phone, doing 180 times 5. Awesome. An easy way to do this is to think about 5 times 100, which is 500. And then 5 times 80 is 400. And then you can add those two together. So 900 degrees. Great, Madison, Gary, Daniel, awesome work. 900 degrees is correct. Now, Chiyoung already gave it to us, but for those of you that don't understand what that x minus 2 pattern is, let's think about how the number of sides or the number of vertices has to do with getting the sum of interior angles for any shape. So for a pentagon, we have 5 sides. Look at the number that we multiplied by. We multiplied 180 times a 3. So we subtracted 2. Well, let's take a look at this 6 and 4. Again, we notice we subtracted 2. With 7 and 5, again, we notice we subtracted 2. So the equation that we now have is this equation. The sum of all interior angles in a polygon are 180 times n minus 2, where n stands for the number, right? N for number of vertices or sides. So using this new information, let's try to find the missing angles in each shape here. For the first shape, how many vertices or sides do you see for this first shape? In the chat. How many sides or vertices? A polygon should always have the same number of sides and vertices, by the way. How many do you see for this first shape? I see Chiyoung has an answer, Daniel has an answer, Gary has an answer, and we're all answering 5. Amazing. Let's see if we're correct. 1, Chidima as well. Amazing. We have 1, 2, 3, 4, and 5. Beautiful. The way that I like to count oftentimes is I like to count from bottom left and go around, or I'll count from the right side of whatever my missing angle is and count from there. So let's count the second one as well. How many sides or vertices does this second shape have then? I'll count with you. I'm going to count with 1, 2, 1, 2, 3, 4, 5, 6, 7. Wow, y'all are way faster than me. Chidinma, Gary, Jiyoung, amazing. 7, right? We have 7 sides here. So here I'm going to put n is equal to 5. And here I'm going to put n is equal to 7. Okay? I'm going to put that down. I've done all the counting that I need to do for now. And this will help me get to finding my missing angle of x. Ooh, exciting work. Let's do it. Now comes the fun part, right? We've already counted. Let's start plugging in and doing some algebra. We know a right angle is how many degrees again? Wow, Daniel already got it. How many degrees in a right angle? In the chat. How many degrees in a right angle? Because right now it's not represented here in the graph. We don't know it unless we know it, and we know it. Jiyoung, Daniel, Chidima, awesome. 90 degrees. Great, Madison. 90 degrees. So what we're saying here, great, Gary, we can add up all these angles and it should equal, right? Let's write these all down. So 90 degrees plus 60 degrees plus 125 degrees plus 105 degrees. Don't forget the x, and this should all equal 180 times our n, which is 5, minus 2. And we just found what 180 times 5 minus 2 is, right? 180 times 5 minus 2 is just 180 times 3, which is 540 degrees. And I don't want to forget my degree measure here as well, 540 degrees. Now let's add up all the numbers on the left. If we add these up, I'm going to group them for the ones that look like they'll be easy to add up. 90 plus 60 is 150. Great, Gary. 125 plus 105 is 230. So 230 plus 150 gives us 380 plus x, and now we can solve for x. What did you get for x? Daniel, I see you've moved on to the second problem as well. Awesome. Way ahead of the game. Love it. I love that you've built speed from last lesson as well. We love that, right? That's how we know we're getting comfortable with this. X is equal to, let's take a look. Well, we have 540, and that's going to equal 380 plus x. So we're going to be subtracting 380 from both sides. In other words, when we move 380 to the other side of the equal sign, it becomes a negative number. So 540 minus 380 would be, great. I love that Chiyoung used degrees here. And earlier, Gary, you also mentioned degrees. Units of measure is very, very important when you're given a unit of measure in the problem. So x is equal to 160, great, Chdima, 160 degrees. And that is our final answer for this missing angle from this first shape. Using the same logic, let's go through this second shape just to practice. Awesome. We're going to add up all of these angles, and we're going to set it equal to the sum of all the interior angles in this polygon, in this 7-sided polygon. So we know 180 times 7 minus 5. We did that earlier. That's already 900 degrees, right? We know it'll be 900 degrees. And all of the interior angles in this shape, we're going to be adding those up. 100 by itself is great. So I got the 100, and I'm going to circle it after I write it to make sure I'm making note that I'm taking everything into account, all the angles into account. Is there a degree sign on the keyboard? That is a great question. I do not know one, but I do believe there is a shortcut to using the degree symbol on Google. But you can check that later. You won't need it right now. You can type it out in degrees. It's often typed out in degrees as well. So you won't have to worry about that. So you can focus more on today's lesson, right? All right, now 111 plus 139. That's going to be 250. I know that because 100 plus 100 is 200, and 11 plus 39 is 50. So we have plus 250 degrees. Plus, well, we know 94 and 131, the 4 and 1 are kind of nice. They add up into a 5. And if we add 90 plus 130, that's 220. So we have 225. And then the 152 will add on later, plus an x. And we are looking for that x. Wow, Raymond, coming in clutch. There are shortcuts. Thank you for looking it for us. Now, let's add up all these numbers on the left. 100 plus 250 is 350. Add the 225, that's 575. Add the 152, that's 675, 677, 8, or no, that's not right. 475, 575, 675, 725, 727. So we have 727 degrees plus x is equal to 900. So what is x equal to? 173 degrees. That's correct. 173 degrees. And now, for both of these answers, we can check to make sure that our answers make sense, right? Make it make sense. And this is the way to do it. I'm going to draw this part in red so that you can see that if we extended this line here, how many degrees are there in a straight line? A straight line creates how many degrees? In the chat, a straight line creates how many degrees? A straight line. How many degrees in a straight line? 180. Thank you, Jiyoung. 180 degrees. Now, our answer here for x was 160. In our minds, we're asking ourselves, does this x look like 160? Does it look close to a straight line? And sure, it does, right? It looks like this right here could be 20 degrees, which would make sense. Again, for this x right here as well, does it look like this x should be less than 180? Yes, it does look like it should be less than 180. And we know that right here. We have 173, pretty close to 180. So we're checking our answer to make sure it makes sense, right? Do it backwards or estimate. Exactly, Daniel. We're basically working backwards. Exactly, to check our work. If it works forward, then it should work backwards as well. Great way to put it. Thank you for that input, Daniel. All right. So hopefully we're feeling a little more comfortable with the sum of all interior angles of a polygon. Now, let's do a couple more. Some crazy ones here. Let's take a look. So as we move on in the lesson, it's going to start getting more challenging. So if you have any questions along the way, there's no bad question. Just type it in the chat. That's the great part of the chat. Use the chat function. All right. So how many vertices or sides does this first shape have? In the chat, let me know. I'm going to start counting as well. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. We have 10. Jiyoung got there before me. 10. So I'm going to take 180 degrees and multiply by 10 minus 2. I see Chidima, Madison, and Gary. Awesome. 10 is correct. And once we get this, 10 minus 2 is 8. So I have 180 degrees times 8. And I'll tell you just off the bat, that's 1440 degrees. Just did it in my head. But you could also do it this way. 8 times 100 is 800. And 8 times 80 is 640. So I know 800 plus 640 is 1440. Now, I'm going to add all these numbers up. And yes, we can use mental math. We can use a calculator. And we'll spend about the next minute doing that. If we use mental math, maybe a minute and a half. If we use a calculator, still might take you a minute to add all these up. So I saved you some time. All of these angles added together except for the x is equal to 1,234. And you can choose to take my word for it or check my work using a calculator. And I'm going to go ahead and subtract 1,234 from 1440. Great, Jiyoung and Gary, I see you. What would x equal then? This part you can do. Try using mental math here. There is a smart way of doing this mentally instead of having to write it down. I do encourage mental math. I do think mental math is one of the most important things you get out of learning math in schools. And it's very beneficial just for like your brain function. 206. Did anyone else get 206? Jiyoung was brave and said 206. Madison, looks like you also got 206. Kind of looks like we're on the same page here. Anyone else get 206, or was it just Jiyoung and Madison? Gary got 166. Okay, a different answer. We love different answers because once again, whoever's right, whoever's wrong, if it's a mistake and you fix that mistake, that's where the learning occurs. So let's check this out. Daniel also said 206. So 206 seems like the consensus, but let's make sure. 1440 is bigger than 1234, so that kind of helps. 40 in the tens place. 40 minus the 34 is 6. So there's the 6. And then we have the 1400 minus the 1200, and that's 200. So we have 206. Gary, no need to be sorry. Never be sorry, right? I love when you all make mistakes and fix those mistakes. That's the beauty of learning, okay? That's the beauty of learning. Don't ever be sorry about creating or making a mistake. It's just a mistake, right? You're not getting graded for any of this. All you're doing is boosting our knowledge and boosting our learning in this lesson. So thank you, right? Never be sorry about that. Now, this next shape, oh, what did I forget here? What's missing in my answer? Did I forget anything? Why did no one stop me? What did I forget here, y'all? X equals 206. What's missing? Thank you, Chiyoung. Chiyoung's been very adamant about these degrees the entire time. Yes, never forget the unit of measure. Degrees. Okay, degrees. Great, Janima. Great, Daniel. We have a regular dodecagon next. And I'm telling you it's 12 sides. Dodeca means 12. Do for 2, deca for 10. Add the 2 and 10. Get 12. Okay? 12 sides. Now, I just want to find one of these x's. And we don't know any of these other ones. But there's a key word here. The key word here is regular. Does anyone know what regular means in the chat? Anyone familiar with this term, regular? If you're taking geometry this year in school, you should know what regular is by now, unless your teacher is behind. What does regular mean if it's put in front of the name of a shape? All equal sides. Daniel knows this because he was here before. But regular means all equal sides, right? All these sides are what we call congruent, right? Congruent meaning they are the same size, same length. Therefore, all the angles are also congruent. Okay, so all of them are an x. So how many angles are there? We know that the sum of interior angles will be 180 times 12 minus 2, which is going to be easy because 12 minus 2 is 10. And what is this going to equal? How many x angles are there in this regular dodecagon? Ooh, Daniel already has an answer. But how many angles are there in this shape? Reminder of what we said earlier. If a shape has a certain number of sides, it should have the same number of angles, right? The same number of angles. So we have x as one of the angles. We have 12 sides, so we know we have 12 x's in total. So we have 12 times an x, because we have 12 x's. And 180 times 10 is 1800. And we divide both sides by 12. What do we get for x? Don't forget your units of measure. Don't forget to type degrees in the chat after your answer. What's 1800 divided by 12? 18 divided by 12. Ooh, I can show you a quick little trick here as well. I'm excited to show you this one. We can do short division here, or some people call it long division. But let me show you a new way of doing this. I know that 12 goes into 1800 at least 100 times. So I go 100 times 12, that's 1200, and I'm left with 600. How many times does 12 go into 600? Well, I know 12 goes into 65 times, so I know that's 50. And then I go minus 600, I'm left with a 0. 100 plus 50 is 150, and that's how I know x is equal to 150 degrees. This way of dividing, of short division or long division, is called chunking. And I actually have a video on this on socials at EddieDoesMath that you can check out after today's lesson. All right, great. I love that everyone is getting there, right? One last practice problem before we move into some new ideas. The total of the interior angles of a polygon is 2340. How many sides does it have? How do we figure this one out? Now we're working a little backwards, right? We're working backwards. We're no longer given the number of sides. This time we want to find how many sides does this polygon have. We're given the total of the interior angles of a polygon. So we start with 2340 degrees. What are we going to be setting this equal to find how many sides this polygon has with this given information? How many sides does this polygon have? What would we write on the other side of this equality? 15. How did we get 15, Daniel? You got there so quick. How did you do it? Divide. Divide what? I know you're frantically typing right now. You're like, we have 2,340 degrees as the total of the interior angles of a polygon. 18 to 2340. Okay, so you must have done the total of interior angles of a polygon is 180 degrees times n minus 2. So how many sides does it have? We're looking for the n. And we're going to use inverse operations. We're going to divide both sides by 180. And that gives us, well, 180 goes into 234 once, leaving us with 540. And that's 3. So that's 13 is equal to n minus 2. Keep in mind the degrees just canceled out, right? We're no longer working with degrees now because n, units of measure, is number of sides. And so n is equal to, in the chat, what do we have? How many sides are in this polygon where the total of the interior angles of this polygon is 2,340 degrees? We have 15. Don't forget, units of measure, 15 sides. 15 sides, right? We have to answer the question that we were given. How many sides does it have? N is equal to 15 sides. Great, Daniel, Shadima, Gary, awesome. I see that you typed degrees, but again, we mean sides, right? We mean sides here. I'm sure you put degrees because we were so used to working with degrees before. But now I'm switching it up, right? I'm slowly going to ramp up the level of difficulty here. And we're already halfway through our lesson. We're more than halfway through our lesson. Crazy how time flies. Let's keep it moving. All right. If you extend the line of any shape's side, you form an exterior angle as shown in the diagram. If you see the green angle here, that angle is outside of the shape, so we call it exterior. Now let's explore what happens when you sum all the exterior of angles of a polygon. And now, guys, I spent about 3 hours working on this animation, so I'm super excited to show you guys this animation. It took a lot of time to make. Okay, it took a lot of time to make. Gary, you already know this. That's awesome. This animation shows that the sum of all exterior angles of a polygon will equal, any guesses in the chat before I show you this animation that I'm really proud of? How many degrees do you think all these exterior angles of any polygon will add up to? The sum of all exterior angles of a polygon. 180, 360? Let's take a look. All right, again, this animation took me about 3 hours, so I'm super excited to show you. I'm going to click it a couple times here. Wow, look at that. A perfect circle. A perfect circle. Wasn't that animation cool? If you thought that animation was cool, W's in the chat, please. All right, thank you for all the W's. But look at this. A perfect 360 degrees, right? A circle, we know, is 360 degrees. And all the exterior angles of a polygon add up to 360. Wow, thank you for the support. All right, so let's put that into action, right? Now that we know this pattern, let's put it into action. The sum of an interior and exterior angle is 180 degrees as they lie on a straight line. The sum of exterior angles is now 360. So now we know the sum of all interior angles. That was 180 times n minus 2, n standing for the number of sides or angles. The sum of exterior angles is even easier. It's always 360 degrees. When dealing with regular shapes, again, what does regular mean again in the chat? What does regular mean? If a shape is regular, all the sides and angles are the same. Great, Daniel. All the sides and angles are the same. All equal sides, all equal. Great. Congruent. Great use of math terminology there, Chiang. Same, Madison. Awesome. It is much easier to work with exterior angles first at times. Gary loved the enthusiasm with the all caps. The exterior angle of a regular polygon is 30 degrees. So what is that saying? One of the angles creates an exterior angle of 30 degrees. Okay, so how many sides does it have? We know that all the exterior angles are the same. And we know all of them added together equals 360 degrees. We know that we're going to get this 30 degrees times the number of sides. So we have n is equal to 360 degrees divided by 30 degrees, which is equal to a dodecagon. Yes, Daniel. Love the use of math terminology. N is equal to 12. Now, let's work with this next one. This time, we're not given an exterior angle. We're given an interior angle. So if we look at an interior angle, and we know the interior angle is 160 degrees, what is the value of our exterior angle? In the chat, what is the value of this green angle right here? What is the value of this exterior angle? If we know that the interior angle of a regular polygon is 160 degrees, all the exterior angles will have what value? What angle, what degree measure will this exterior angle be? We know that a straight line, the sum of interior and exterior angles, is 180 degrees as they lie on a straight line. And we know the interior angle is 160 degrees. Chiyoung, very brave. I see the 20 with the question mark. We love when we try, right? Half of the work in math is just that taking that first step, not being afraid to take that first step, not being afraid of being wrong. So I want all of you to put your educated guess, what you think this exterior angle degree measure will be in the chat. What do you think this green would be? When does class end? 7 p.m. Lessons are always 1 hour, exactly. If you have to head out for whatever reason, all my lessons are recorded, so you can come back. 7 p.m. Pacific time, by the way. 10 p.m. Eastern time, yes. So we have, what's the degree measure here? 20 degrees, right? 160 plus 20 is 180. Chiyoung, great guess. So now, we have our exterior angle. I can take the sum of all exterior angles and divide by 20 degrees, our one exterior angle, and that gives me 18 sides. So a regular polygon with an interior angle of 160 degrees will have 18 sides. All right, now we've talked about interior angles, we've talked about exterior angles. Let's practice these exterior angles. Let me know what to do for this problem. The exterior angle of a regular polygon is 24 degrees. How many sides does it have? What do we do here? What do we do here? Now we're practicing our knowledge of exterior angles, right? We know that if we were to draw something like this, we know the exterior angle is 24 degrees. I want to know how many sides this regular polygon has, and that will be, we know that n will equal 360 degrees divided by whatever the value of that exterior angle is. Great, Daniel. Thank you for helping us out. 360 divided by 24 degrees, and that will be 15 sides. Okay, 15 sides. All right, I'll give you a little bit more time for this next problem, okay? The interior angle of a regular polygon is 175 degrees. How many sides does this one have? Great, Gary. I'll draw this out for us. So the interior angle is 175 degrees. I have to first find what is the value of my exterior angle. And once I know that, I can find my n, right? The number of sides will be 360 degrees divided by whatever that question mark is. And let me know in the chat what you get for this problem. We have an interior angle. We know it's a regular polygon. And because it's regular, we know that all the exterior angles will be the same. It should be more straight. Great observation, Daniel. I'm going to say all my diagrams are not drawn to The figure is not drawn to scale. That's what they always write under all those pictures. Great, Madison. Yes, the exterior angle here is 5 degrees. So n will equal 360 degrees divided by 5 degrees. Chiyoung gave us an answer, 72. Is that correct? Is 360 divided by 572? It is. And n is equal to 72. Great, Chiyoung and Madison. Love to see y'all in the chat being more active now. It's like starting to turn, right? Our gears are starting to turn. We're starting to get it. We feel good. And this is exactly where we're going to up the level again, right? I'm trying to get you to certain levels. And from where we started today, right? From where we started today at the beginning of this lesson, think about how much you've already learned. We're only going to get better from here. And you know what the great part is? You're going to be able to show some of these challenging exam style questions you're about to see right now. You can show it to your friends and they're going to have no idea how to solve it. And you're going to know exactly how to teach them. And another great part of learning is that if you can teach someone something, that's when you know you really get it, right? That's the beauty of it. When you can teach someone something so that they get it, that's when you know you really get it. And that is a beautiful feeling, right? That's the most human feeling you can have. So let's take a look. Here are some practice problems. Don't get intimidated. But I know by saying that, you all just went, whoa, how am I going to do these problems? But we're going to take these step by step. And after we do those problems, I'm going to give you a little bit of time to think about this next one, okay? So let's try these together. Practice. Exam style problems. These are exactly the types of problems you would see on the SAT. I know some of you might have already started to prepare for that. The SAT, ACT, any type of Regents exam that you're taking, this is perfect practice for any type of exam you'll be taking in the future. The diagram shows 2 identical regular polygons. Yes, these are congruent. And you know because identical and regular. Pentagon, meaning 5 sides each. Great, good information. Find the value of the angle of x. What information do we know that can help us to get to this value of x? Any ideas in the chat? I want to see if we can start thinking about this on our own as well. Because once I explain it, you're going to know exactly how to do it the next time you see it. But if you're able to kind of guess your way through this at the start as well, you're going to remember it even better later on. How can we find the value of the angle x here? I know all the sides are the same. All the angles are the same. Divide 5 to 360. Oh my goodness. Why would we do that, Daniel? That is a great idea, by the way. What led you to think like that? Divide 5 by 360. Or divide 5 into 360. What would that give us? Dividing 360 by 5. We're familiar with working with 360 because we just learned that the sum of all, exactly double, the sum of all exterior angles is equal to 360 for any polygon. So let's take a look here. I'm going to take this exterior angle right here. If I can find the measure of this, would you agree? Yes, so all are equal. Exactly, Daniel. Would you agree that that would be equal to this same one? So if we're able to find one of these, then I can double to get x, right? So for a pentagon, I see Daniel is getting really excited here, getting to the answer already. Let's check it out. So we have a pentagon. A pentagon is 5 sides and 5 interior angles. So for an exterior angle, we can take, 360 degrees divided by 5 exterior angles will equal 72 degrees. So in red, this will be 72 degrees, and this will also be 72 degrees. So in the chat, let me know, what do you think x will be equal to? X will be equal to what in this case? Since the diagram shows 2 identical regular pentagons, find the value of the angle x. Daniel is telling us to double, spamming 144. Is everyone else getting 144 as well? Yes, exactly, Madison. This is the same as our animation earlier, right? We know that if I were to draw this out even further, we know that all these question mark angles, 1, 2, 3, 4, 5, all of these exterior angles will add up to make a circle, meaning 360 degrees. So going backwards, 360 degrees divided by 5 will give us the measure of each exterior angle, which is 72 degrees. And therefore, we know x will be twice this exterior angle. So x is equivalent to 144 degrees. Makes sense. It was cool. Yes. Oh, yes, Chidima, that's what we're looking for. The aha moments, right? Now, I'm going to tell you right now, Madison, great. I'm going to tell you right now, these questions are not easy, right? These are challenging problems. I'd be surprised if you saw any like of this level of difficulty in your schools, right? I'm really trying to push you, right, above what you think you could do, right? That's what I'm trying to do here, so that when you go back to school and you're taking these types of exams for these types of for these lessons, for these concepts and skills in your schools, they're just chump change, right? You're gonna know how to do these, right? You're gonna know how to think, you're gonna know how to dissect these problems. And remember, the first step is always the hardest. Just go for it, right? Do something, you're gonna know, most of the time you'll be right. All right, let's take a look at another one of these problems. The diagram shows a regular hexagon. Find the value of the angle x. All right, so this is a hexagon, a regular hexagon. All right. Great. This time, will we have 3 triangles? I'm going to roughly draw them here. We have 1, 2, 3, 4 triangles this time. Okay, we have 4 triangles this time. Great, Gary. I love that we tried that method. And I love that we tried that method, right? That's the perfect way to go about this. So just draw out the lines, and we have 4 triangles. So we know that the sum of all interior angles here will be 180 degrees times 6 minus 2, which is 180 degrees times 4. And y'all are typing in the chat here, 720 degrees. Awesome. Great. Gary, I saw you were incorrect at first, but you fixed your mistake. Beautiful. And Daniel, I see you have 720 as well. Awesome. So we have 720. Now, why does this help? Well, we can see here that follow my thinking here, if we're able to find this angle, right? Exactly. These 2 red angles that I'm about to draw are going to be congruent. Why? Because in geometry, we learn that opposing angles of congruent sides are congruent, right? So we know that these 2 red angles will be congruent. And how many, what is the sum of the 3 angles of a triangle? In the chat, really quick, easy answer in the chat. What is the sum of the 3 angles of any triangle? Of the 3 interior angles of any triangle, what is those 3 angles added up together? I see Daniel put 180, super quick. Awesome, and that is correct, right? 180 degrees. So how does that help? Well, 720 divided by the number of interior angles in this shape, so 720 degrees divided by 6 gives us 120. So we know that this is 120. Wow, Gary, nice. Or 108, what is 720 divided by 6? All good. That's 120, right? Awesome. So now, because we know this one angle is 120, what would be the measure of these 2 red angles here? In the chat, I'll give you a couple seconds to think about this one. What is the measure of each of these red angles? Each of these red angles, knowing that the 3 angles in a triangle add up to 180 degrees. We know that one of the angles is 120, so the other 2 angles have to add up to 60, and Chiyoung and Daniel, awesome, 30 and 30, right? Each of these have to be 30 degrees. But guess what? This is the fun part. This entire angle is 120 degrees. So how do we get to x? If we know the entire angle here, the entire interior angle of the regular hexagon is 120, and we know that this red angle is 30, how do we get to x? X will equal 120 degrees. Subtract exactly, Daniel. 120 degrees minus the 30 degrees, and our final answer is 90 degrees. And that makes sense because it looks like a right angle in the diagram as well. Great, Daniel. Great, Shadinma. Awesome work. Let's keep it going to this monster problem. The diagram shows a regular pentagon. So if you notice here, I'm going to try to trace it in green. This pentagon right here, 5 sides, right? 5 sides. Wow, that's a terrible job. All good. But as long as you see the pentagon, we're good. And the regular hexagon, 1, 2, 3, 4, 5, 6. That's the regular hexagon. They are overlapping. And we want to find the measure of x. Oh man, our head's starting to hurt already. We don't know where to begin, but we know what we know. What do we know about, we just worked on this problem. What do we know about all the interior angles of a hexagon? What does that equal? Well, we go back. A hexagon. Each of these interior angles equals 120. So what if we started off with that? So 120, 120, 120, 120, 120. Great. I'm not gonna mark this one because I'm trying to find x here. I'm trying to find x. How about for a pentagon? What is this the value, the degree measure of the interior angle of a pentagon? I'm gonna do this one in green. Well, a pentagon is 180 times 5 sides minus 2. 5 minus 2 is 3. And 180 times 3 is 540. And we're going to divide that by 5. So I know, Gary, earlier you said 108. I think this is where that would come in very handy. 540 divided by 5 would equal 108 degrees. So all of these, Great Chiang, all of these green angles is going to equal 108. So here I have 108 and 108. Does anyone notice anything about this shape that's overlapping? What would you call this shape? Right? Oops. I have to go back to pen. Oops. No highlighter. Pen. 108. Not a hexagon. Great. What else? If I were to outline this in yellow, what is this shape right here? How many sides does this shape have in yellow? It's a pentagon. It's a pentagon. And we just found that in a pentagon, what is the total number, what is the sum of all interior angles of a pentagon? We already found it. 540 degrees. So how do we find x? Take 540 and set it equal to x plus 120 plus 120 plus 108 plus 108. Isn't that crazy? We just found x. Here's x, right? One of 5 angles in a pentagon. One of 5 angles in a pentagon. We know that a pentagon, the sum of interior angles is 540. So we add up 120, 120, 108, 108, and x, and try to find x. 120 plus 120 is 240. 108 plus 108 is 216. So we get, as Daniel said, 456. And Chiyoung already got the answer. So did Madison and Daniel. 540. Don't forget our degrees. And so x is equivalent to 84 degrees. It takes 44 to get from 456 to 500, and then we tack on that 40 to get 84 degrees. And can you believe it? This is really high level thinking here. Player 456. I know, isn't that crazy? Squid Game. Very very disturbing but real show that is, right? All right, one last question, and I'm going to work you through this one. This question actually showed up on the SAT, right? This question actually showed up on the SAT math section, and here it is. How many sides does a polygon have if the measure of each interior angle is 5 times the degree measure of each exterior angle? Let's draw this out. Here's a straight line, and here's the interior angle, right? This is the interior angle, and this is the exterior angle. Now they're telling us the measure of the interior angle is 5 times the measure of the exterior angle. Let's call it x. So if our exterior angle is x, what should we call our interior angle, knowing that our interior angle is 5 times that of the exterior angle? What should we call this interior angle? 5 times x would be just 5x. Exactly, just 5x. Now, these two angles added together would give us how many degree measures in a straight line? How many degrees in a straight line? We know it is, if we add an interior angle with an exterior angle, Jiyoung can always count on you for that one, 180 degrees. Great. And this will equal 5x plus x. And what is that? That's just 6x, 180 degrees. And so x is equal to, what do we get? Jiyoung, great, got there before me, 30 degrees. And this is a type of question that you'll be able to do in less than a minute. On the SAT math section, you get about 1 minute and 35 seconds per problem. But now, guess what? With me explaining it word for word, we just did it in 1 minute and 30 seconds. So you'll be able to do these types of questions in less than 30 seconds after learning with me. All right. If you're still in the chat, give me a W. If you enjoyed today's lesson, give me a W in the chat. I have something super, super special to share with you today. Call your parents over, call your guardian over, whoever, whatever adult, call them over. I have something super special to share with you right now. Here it is. Our lesson may be ending, but your progress does not have to. My EddSpace Geometry Full Year course will start on October 6th. It will start on October 6th. Each course is going to have 2 of these, exactly like today, live and interactive lessons each week. And geometry will be every Monday and Wednesday at this exact time, 6 to 7 p.m. Pacific or 9 to 10 p.m. Eastern time. All my lessons are recorded. So if you have any extracurricular activities or an event and you can't make that lesson, guess what? It's going to be recorded and you'll be able to access it. Professionally designed workbooks like the one you were able to use today. Practice with exam-style questions. You're not getting this today, but you're always going to get practice exam-style questions after each lesson that you can practice. And I won't leave you hanging. I'm going to make detailed video solutions on all of your practice problems so that you're not just looking at the back of the book for the answer, but you can see exactly how I solved it as well, right? Yes, Mondays and Wednesday nights, just like today. But how much is it? In the chat, take a guess. How much do you think I used to charge per hour? How much do you think I used to charge per hour, per student back in the day when I used to be a private tutor? 20? Wow, that's really cheap. Reminder that I have 9 years of teaching experience. I graduated from UCLA with a math degree. Wow, Daniel was here already, so he gave away the answer. But I used to charge a minimum of $100 an hour and up to $200 for those studying for really crucial exams because they're more higher impact. Yeah, making money. But with tutoring, families always have to choose between what works and what they can afford, right? Effectiveness versus affordability, and you can never have both, right? If a tutor is too cheap, usually not the most effective. If someone's really good at teaching, probably really expensive. And that's why we created my EddSpace. You get all of this, right? That would mean about 7 to 8 lessons per month because in a month there are 4 weeks times 2 would be 8. All this for $99 a month, which is 8 times cheaper than what I used to charge as a private tutor, right? 8 times 100 would be 800, and 99 is less than 100, so it's actually more than 8 times cheaper, slightly, right? If we were to do the math. And why stop there? Because you're here today and you experienced my live lesson, I can give you 20% additional discount on our annual package. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. And that's because I'm really confident that if you join my course, you're going to love it. You're going to learn. You're going to be ahead of your classmates. You're going to ace every test, right? And that's why I provide this full refund guarantee. It's because I'm confident you're going to do well in my course and therefore in school. It's a first come, first serve basis. So it is a limited time offer. And if you're interested, text code word START to this number. This is my number. You'll be speaking with me, 512-900-1283. If you don't want to copy this down, then you can take a screenshot. You can take a photo of this. You can scan the QR code and it'll prompt you automatically so that you're not texting the wrong number. It'll automatically text code word START to this number, and we can start talking about you joining this course and starting your journey with me at My Space. And I'm super excited to have all of you there. Chat was popping off today. It was super fun. This is what it could be like every single lesson starting on October 6th. Join the fun, right? If we do the math, and I can do the math with you over text as well, it comes out to less than $11 an hour, which is cheaper than, I can guarantee, any tutor you can find. $11 an hour is absolutely an insane offer, but that's why that's why we created My Space, right? To make learning fun, approachable, and accessible to everyone, right? No matter where you come from, no matter what the background, affordable, accessible, and effective, right? The best education you'll ever get. If you enjoyed today's lesson as well, I'm on socials, EddieDoesMath, EDDIE does math. And all the lessons will be by me, Jiyoung. That's a great question. The number of students can, go as high as possible, right? But I can assure you, the more students we have, the more questions we're going to have, and almost a guarantee that whatever question you ask will get answered in the stream, in the lesson, every single lesson. So it's just me. I'm teaching all the courses. I'm teaching grade 6 through 8 math, basically pre-algebra, algebra 1, geometry, algebra 2. If you have siblings, I also offer an additional sibling discount if you get that extra course, that additional course. So keep that in mind as well. If you have any siblings, if you have any family members, if you have any friends that are, higher grade levels or lower grade levels, all are welcome. And all they need to do is text code word START to this number. And I look forward to speaking with all of you. Y'all were a pleasure tonight. It was a W stream indeed. Jiyoung, Daniel, Madison, Chidima, Gary, Raymond. Beautiful work today. Love the energy, and I hope to speak with you soon via this text. So thank you for your time. I'll catch y'all later. Bye, everyone. Yes, W indeed. Yes, let's look at the animation again. I did work really hard on it, so I'm so down to show it again. There it is. Oh, man. It's a beautiful animation, isn't it? All right. That's enough fun. Bye, everyone. Enjoy the rest of your evenings.